Among Us, one of the biggest multiplayer titles of 2020, and we've got a single-player remix for you on Scratch. We're going to teach you all about it in this special three-part series coming right up. Welcome back to the Chromeworks studio in beautiful Ottawa, Canada. I'm Andrew Tomec, your technology teacher, back again with another great Scratch lesson today. We've got something fantastic lined up for you, the smash mega hit game of the year. This is like the Minecraft of 2020, Among Us. All you guys are playing it right now, and I've had lots and lots of requests to find a way to bring it into Scratch. Now, multiplayer in Scratch is really hard to do, and I don't want to teach you guys how to do it, and I think it's buggy even at the best of times. So I put my coding genius, Jeffrey, my son, on the case, and he came up with a fantastic little single-player experience here that captures a lot of the look and feel of Among Us without actually having the multiplayer elements involved. So it's a single player game where you are the imposter running around a room inside the spaceship trying to murder all of the other participants of the game. They're all AI players who were wandering around the game. You have to basically take them all out one at a time without being noticed. And as soon as you're noticed, it's basically game over. You get pushed out of the airlock yourself, just like in real Among Us. So it's a lot of sneaking and skulking around, trying to get rid of the whole crew without getting detected. And it's quite a bit of fun for a little fun arcade game. Uses some really great, interesting coding concepts. As usual, we've kept things as simple as we can for kids your age. There's a few little pieces in here that involve a little bit of trigonometry and things like that again. And you don't really need to understand the underlying concepts to do it. I'm going to teach you in a way where some of these blocks are going to be done for you in advance, and other ones are, we're just going to kind of give you a quick understanding. You don't need to know all the math to make this work, though. And the great thing is that a lot of these concepts you can use in your own projects moving forward without necessarily understanding the math. So that'll all come in time when you're in high school. But right now, just knowing how to use these things in a coding context is really helpful for you. It'll let you up the level of your games and do some really fantastic work, guys. So without further ado, let's get on to it here. So this is our Among Us starter file, which you can find at my website, and you can also find a link to this inside the description for this file. So as is always the case, I've given you all the sprites and backgrounds and sound effects that you'll need to make this game. Let's take a quick tour around and see what's already here. I'm on the Imposter character here, which is your main character. You'll see that these are the original sprites from the video game. So this is going to look really authentic and really legit in the final thing. We've got lots of different animations here, all of them named differently. So we've got a walking animation here. Well, actually, there's only walking in this particular game. But we're going to be using the Chromeworks animation system, our patented animation system, to get this guy going through his different animations for idle and walking around, just based on the naming of these sprites. Yeah, we have two standing around sprites for passive movement, and then walking sprites as well that'll have him bouncing around the screen. There's an identical copy of this guy named Crewmates that we're going to be using some color effects so that you can tell the difference between yourself and your crewmates. And we've got some other sprites here. They're not, all of them are not all that critical to know about right now. We have some authentic screens from the original game, like dead body reported here. And here's the beginning screen with the imposter. We've got all the original sound effects and some really great sounds here for you. Like, I'm not even sure where the sound effects are in this file. Oh, here's a body reported. So you can see really authentic sound effects from the game, really, really cool stuff. So in the end, this is going to look and feel a lot like the original game, I promise you. Okay, so let's have a look at the code here. We'll get started by coding the imposter. So we're going to be doing this as a three-part lesson. Today in part 1, we're going to get the imposter working. We're going to be able to make him run around the screen and stay away from any objects that he's going to bump into, so that he's bouncing off of tables and walls. We're going to get the crewmates, all the people who you're trying to dispose of, moving around randomly too. At the end of today, they're not going to be able to see the imposter, and you're not going to be able to do anything to them. We're just going to get them moving around randomly. In part 2, we're going to get the rest of the game mechanics going so that you can catch these guys and toss them out the airlock, as I said, and get detected by them. And then in part 3, we're going to do some interface elements. We're going to get splash screens and music and all the other stuff that's going to make this really look and feel like an Among Us game. We're going to get all that stuff running. So I'm inside of the imposter sprite, who's going to be your character. In this version of the game, you're always going to be the imposter, trying to annihilate your opponents. As you can see, there's already some code here on the screen. I'm not going to reinvent the wheel here because I already went over a lot of this content in my RPG series. This is the Chromeworks animation system, kind of a pre-packaged animation system that you can use to animate your sprites in any video game you choose to use. You just need to use this custom block and this enabling block down here. And I have a separate video. If you look at my RPG remix guide, you'll see very good instructions for how to use this stuff in your own games. It's all about how the sprites are named. So for example, here we've got 2 standing sprites for his idle animation, then a whole bunch of walking ones. So we can use a custom block here to, let me show that to you, and basically use that to set an animation for these characters. So we can type in the word standing here, for example, and then the speed at which he's going to do it and whether it's looping or not. And just by entering that information and embedding it in your code, you can switch from an idle animation to a running animation to a fighting animation if that was the case in your game. So a really cool couple of blocks of code that I really think should be in your backpack and that you should learn how to use. It would be really helpful for you in all your game projects. Okay, so I'm not gonna teach you guys how to code that part. There's one more custom code block here that I will not teach you as well because it's just a little bit too complicated for kids your age. This is a little block of code here that is basically determining whether you're colliding with one of the tables on the screen. So this game is set entirely on one map, the Skeld map, if you guys have played Among Us before, and it's the cafeteria where you're going to be running around. So there's a bunch of tables set up in the room and you have to bounce off of them. Now, doing a collision off of a round object turns out to be way more complicated than you think it would be. And so we've got a bit of code here that uses some trigonometry and square roots and stuff that's just a way complicated for you guys. Don't worry about how it works. The basic idea, though, is that it's going to measure how far you are away from the center of the table, and then it's going to slowly move you out of it. So as you bump into the table and try to overlap it, the computer is going to be pushing you away from it. Not all at once, so you'll pop back, but kind of gently pushing against you as you're pushing against the table. Really nice, elegant piece of code that Jeffrey's written here, and someday maybe you'll understand it. Maybe I will as well. I really haven't had a chance to have a look at it in great detail. I understand how it works, but the math in it just would take me 15 or 20 minutes to sit and understand because it's quite complicated even for adults. So kids your age, I'm not even going to recommend you look at it. Just use my code and trust me, it'll work. The rest of the code in this project, though, is all stuff I will be able to explain to you, and so that won't be a problem at all. We should probably start coding by now, so let's get going to it. I'm going to take all this prefab code and just shove it on the side here and start working on them to the left of the code here. So I am working on a starter file, as I said, that you can find on my website that has all of this stuff all attached to it, and we're just going to start coding from here. Okay, so let's go start with a green flag, as we always do. A green flag signals the start of your program, usually. Okay, so we're programming the imposter to move around the screen and bump off of walls and bump off of tables, basically. So let's start with a show block. We'll go to our looks menu here and grab a show block, and then we'll make sure he's invisible because at times we'll be hiding him, and we want to make sure that that he starts off available and visible. All right, now we're going to use one of these animation blocks right away. We're going to set our animation to an idle animation because we haven't given it any keyboard input yet. So I'm going to type in the exact spelling of the idle animation, which is called capital S standing. You'll see that, so if there's multiple costumes, it's always the first version of the costume has no numbers in it, then you start adding numbers after. We have walking, walking 2, walking 3, etc. And so Scratch will look for the first version of the word walking and then start cycling through all the animations that say walking in them and then keep looping around depending on what you typed here. So here's the delay time, 0.07 seems pretty smooth. And 1 will indicate that this is a looping animation. So instead of just playing the animation once, it's going to keep doing it until it gets a new command. Okay, so we have a variable here that we have to initialize. It's called closest distance to imposter. And this variable just keeps track of, basically the software is going to pick which of the crewmates that are playing against you in the game is closest to you and how far away he is from you. So to initialize this variable, we're just going to set it to an impossibly far distance, 1,000 pixels, and that's going to be updated with the proper number in a little bit. So it's just, the distance away from you is very, very important in this version of the game, of course, because that's going to determine whether you were seen when you clobber one of your opponents, basically. Okay, so let's get a starting position for our character. We're going to put him roughly in the middle of the screen. The numbers I have here are 0x and 49y. I guess 50y wouldn't be a tragedy either. And let's get him into the proper costume for standing. So let's go to looks, and we'll switch costume to the first standing animation. All right, so there's, we just wait 3 seconds for all your characters to initialize. Basically, all your opponents are going to appear around the central table on the screen, and they're all going to pop in there and spawn at some point, but not yet. So right now, let's have them wait for 3 seconds. So you're going to, before you're allowed to move around the screen, you need time for all your friends to, or enemies to spawn around the screen. They're kind of frenemies, aren't they, right? They're your crewmates who you happen to want to backstab for some reason. Okay, let's put a forever loop in here. And inside here, every time we go, so every frame of animation, we're going to do a whole bunch of stuff here. First of all, we're going to set a bunch of variables. Let's go and set variables again. We have to actually do this 3 times. So let's just duplicate a bunch of times, and we're going to set 3 different variables all to 0. The first one is called move to this frame, and so that's just going to track whether your character actually moved this time around the loop. The second one is called move X move, sorry, and the other one's called Y move. So we're using variables to control our movement. We're going to do our movement scheme in a second with our keyboard. And what's happening here is instead of telling you to move a certain X or move a certain Y, we're going to move this variable, and it's not actually going to move till the end. We're going to put that number in, so when I move left, my X move is going to change by -1. But then that X move, we're going to do some math on it to normalize the direction, which means that when we're going around on an angle, we're not going to be able to cheat, because everyone knows that if you go diagonally from one point to the next, due to Pythagoras and the way that triangles are made, you're basically making a little triangle here. If you move from one point to another, you can imagine it as a right triangle. So if you moved left all the way, that would be one distance. If you moved up all the way to the next square, for example, that would be a certain distance. But if you go diagonally over to the next square, it will be a shorter distance. It'll be about 0.7 of the existing distance, roughly. So we compensate for that. Otherwise, every time you move diagonally in a game, you're going to end up being able to cheat and move faster. And so we have to do a little bit of math on these things to straighten out your movement speed. It just helps the realism of your game. So it's something that I like to do in all the games that are platformer type things where we walk around the screen. Okay, we're going to do some keyboard inputs now. Let's go grab an if statement and put it inside the forever loop. And we're going to grab an or because we want to do 2 different kinds of keyboard inputs as we like to do in these games. Let's go to our sensing blocks, and grab some keyboard inputs. I'll put one in each of these spots here. So the first direction we're going to do is right. I'm going to move some of this stuff out of the way because it's getting a little awkward. There we go. All right, so if I move to the right, my right arrow, or of course with the WASD system, if I hit the letter D, that will also move me to the right. And all we're going to do is say that if I held the right key down, we're going to change that variable. So let's change xmove by 1. All right, so that number is going to go up by 1. The nice thing about this kind of a keyboard system is it'll work really nicely with diagonal movement. If you hold 2 keys down at once, you're going to change the X move and the Y move, and that'll move you diagonally, of course. Okay, so rather than reinventing the wheel here, let's right-click on the word if. Remember, it's 2 fingers. If you're on a Chromebook, just hit it with a peace sign, and we're pointing at this thing. Duplicate. Move it down below the next one. Look and see that they're parallel to each other. We don't put the one inside the other one because that will mess up your code. All right, and so for here, we're going to say left arrow. And the complement to that is the letter A, which is our left. Okay, and with that one, we're going to change our X move by -1. All right, let's duplicate both these. We actually want 4 of these directional movement commands. So the next one down will be up arrow or W. And in this case, we're going to change the Y move by 1. And then we're going to change the Y move by -1 when we hit the down arrow or the S key. So now we've got our WASD movement and our arrow key movement all working nicely here. If you click the green flag right now, absolutely nothing will happen because we're changing variables. We're not changing where anything is positioned yet. That comes a little later, so be patient, folks. All right. Now we're going to do that normalization. There's different ways to do this, but Jeffrey just kind of approximated it with this code here. So we're not actually going to calculate it to the last decimal point the way we could. And he wanted to do it a different way, but I insisted to keep it nice and simple here so I can explain it. So what we basically want to say is if we're not moving at a 90-degree angle, if we're not moving straight across like that or straight up and down like that, then we have to apply this normalization equation to it, basically. So we're going to say if we're not X moving at a 0, and if we're not X moving at a Y, meaning if there's any movement up or any movement left, then we're going to compensate for it, basically. So let's go if not. We'll need a not command here under our green blocks. If not, X move is equal to 0. So let's grab an equal sign here, and we're going to find a little bubble here that says X move. That's our variable. So basically, if we're moving in the left-right direction at all, so our X move is going to be greater than 0. So if we are moving left or right, or any combination of left and up or whatever, then we have to normalize it. So we normalize it by setting a variable. Let's go ahead and set Y, hold it. So if not, X move is equal to 0, then, so if our X move isn't 0, if we're not moving across, that means we're moving up a little bit, and we have to normalize our Y coordinate, basically, right? And then when we do the Y coordinate later, we're going to normalize the X coordinate. That's the way that works. So if X move is equal to 0, then we set Y move to Y move times something. So let's go grab our multiplication sign, which is a little star, and we'll put Y move in there. Y move times 0.707. This is our closest approximation to what Pythagoras would do. So basically this is 70.7% shorter distance than just going straight across a line. And that's just a nice close approximation that will work nicely for our game. I'm duplicating that block now. I'm going to change the X move here to Y move. And I'm going to change Y move to X move and change Y move to X move here again. So if not Y move equals 0, then set X move to X move times that number. And there's one more block I forgot to add in both of these, and that's that we have to tell the computer that we actually moved this frame. So let's go set moved this frame to 1. I'm going to duplicate that and run it down here below as well. There we go. Okay, we're making some progress here. So now we normalize our direction so that no matter which way we move, we're always moving at the same speed. And we're also going to point in direction here. Let's go grab a motion block and we'll go point in direction. Now this is going to be out. Oh no, it is inside the if statement. So inside the Y move if statement, this, no, the X move one, sorry. So I put this in the wrong place. So inside of this one that says if not X move, at the very bottom, we're going to put a block here that says point in direction. What this is going to mean is when we're moving left and right, it's going to check and see whether we're moving. So the number is going to be either 1 or -1 at any given time, right? So if it's a 1, we're going to point in direction X move. So let's go grab the X move variable. So basically you're going to be pointing in a direction 1 or a direction of -1. Now that's going to basically turn you on an angle. It's going to move you just the tiniest bit to the right or the tiniest bit to the left. But because our character is locked, we've taken the trouble to lock our character here so that he spins around, so that he's not allowed to spin around actually. And so what that's going to end up doing is as soon as that becomes -1, he'll flip to the left. Only lock that direction left, right again. So just by changing this variable to this or this or this, we're going to be able to get him to flip around in either direction. So that's kind of a cool and simple way to get him pointing in the right way. We don't need to do it for Y because when we're moving up and down, it doesn't matter what direction we're facing. It's only if there's some left or right movement that we need to correct for our facing direction. Okay, so we're facing in the right direction, but we're still not moving yet. So we're going to put something else inside the forever but outside of these if statements here. And let's go ahead and do that. We're going to go to our motion blocks here. And we're going to change our X. So change X by, and we're moving the speed of 2 here. So we're just going to take our X move speed and multiply it by 2. So let's go ahead and grab a time symbol times 2, and we'll pop X move into that. And let's duplicate that. Oh, actually, we can't change this to a change Y. So let's go grab a change Y block. Change Y by Y move times 2. I'm just going to right click on this instead of grabbing a new bubble. I don't know if you guys were aware of that, but you can right click on any variable and get a new value for that. Just a nice little time saving method. As you guys watch me code, you'll notice that I'm using a lot of shortcuts and right clicks to copy stuff and move stuff around. If you're doing a lot of coding, it's really nice to use these kind of shortcuts to do things faster. Learn to code the way that I will and that I do, and you're going to end up being a lot more efficient and getting stuff done a lot faster. You don't have to retype the same things over and over again in Scratch because you can just copy paste everything you need. In text coding, that's even easier because you can just copy text little blocks of code, and you can even do search and replace. So I can go through all the X's and change them to Y throughout my whole code, for example, and fix it or change the name of a variable or something that way. So there are advantages to text coding for sure. Okay, we're ready to go ahead and test our movement. I just noticed though that I had blown up the imposter, made him bigger so that I could use him in one of my little promotional videos. So I'm going to change it back to a size of 20% here, which is the size he should actually be on the screen. So that'll make a bit more sense when he's running around here. We don't actually see our area that we're running around here in either. So let's change our backdrop just for fun so we can have a look at the actual cafeteria that we're going to be in here. Okay, so now we're on the right map, and let's click the green flag. And so all our opponents are going to be lined up around this central table when the game starts, and then they're all going to disperse into random directions, basically. Let's try moving around here. Beautiful. So the animation still isn't working properly, but you can see my arrow keys are working, and there's my WASD as well, working quite nicely. And so it's the start of me moving around the screen. Beautiful. Okay. Now you can see the collision detection isn't working yet. I'm allowed to stand on the tables. It's like a wild party here. I can jump up and down on the tables, and I can even go through the walls, which is a little crazy. So we're going to get to that in a couple of minutes. Okay, so let's have a look at the code from here. Now, next we do get into the collision detection. We're going to need to send our code off to test for collision here. Now I'm going to do something here that I've done in a couple of other games that's going to seem a little bit counterintuitive to you. I keep telling you about how to use loops to make things more efficient, but sometimes loops actually slow you down. In the case of collision detection, if I want to detect whether I'm touching something and then move away from it, if I'm moving at a speed of 10 and I stop, I could be 1 pixel inside the object, or I could be 10 pixels inside the object, or I could be 3 or 4 pixels inside the object. So if I move it back 10, it's going to move really, really quickly and appear really jittery. I want it to move back a little bit at a time until it's just to the edge of the screen. Now, if I check and move back and then loop around and check and do it again, it's going to happen really slowly because Scratch's frame rate is locked. You can't make things run faster than the default frame rate unless you're in turbo mode. And there are some games that are made to run in turbo mode where your frame rate isn't locked. I haven't talked about turbo mode before, but it's a really cool way to do very complex projects where there's a lot of math involved and where you don't want to artificially slow down your projects. Turbo mode's not a good idea for playing most games though, because it'll just make them run crazy fast, like super fast. Okay, anyway, so because we don't want to go around a loop, every time we go around a loop once, we change frames once, and we don't want to change frames. We want all this collision detection to happen all at once. So what we're going to do is test for collision over and over again. We're going to test for collision, move back 1, test for collision, move back 1, and keep doing that 5 times until we're sure that we're not inside the wall anymore. Basically, it'll appear much more smooth in the end, and it's not going to be jittery, and it's going to be very, very fast and responsive because we've only gone around the loop once every time we did this. Okay, so we have to make a custom block here called test collision. Let's just click on the make a block button, and then we'll type in the name, which is test collision, and this is going to test our collision against the wall, see if we're colliding with a wall in any given moment. So I've got my defining block here. This is what's going to determine, or this is where we put all the detailed code for how to test for collision. Let's put an if statement in there. If I'm touching the collider. Now the collider is just a object, let me show it to you here, that is shaped exactly the same as our room, basically. So it's the outer walls of our room, and that's what we want to bump into. It's superimposed over the top here, and Jeffrey did some fancy Photoshop work here to get this all set up so that it's exactly sized the way that our cafeteria on the scaled map is looking. So if you were going to customize this and create new rooms, you would have to create a totally new mask, and you'd have to steal new graphics. It would be a little bit complicated, but maybe at the end of this, I'll show you how to do a new room for this map if you're interested. Let me know in the comments. All right, so we were defining that block. We're back in the imposter here. If I'm touching that edge, so let's go touching, and the sprite is called Scaled Cafeteria Collider, or Scaled Caf Collider. In there, let's go set a variable first. We're going to set a variable called, it's just called temp variable. So where is that? Temp variable. We use this a couple of times, and it's just a disposable variable that we're going to use for a second, and then we can forget about it. It only works in that one frame of animation. So we're going to set temp variable to our current direction. So let's grab the little bubble at the very bottom of our blue blocks called direction. And so we'll make sure that number, so let's say I'm moving to the right, that number 90 would be fed into the computer. Basically, our direction is 90. And now what do we do with that number? Well, first of all, we're going to point towards the middle of the screen. Jeffrey set up a block here called eject area that he's going to use over and over again inside this project. I can make it visible, but right now it's placed right in the middle of the room. And so he's just saying point towards the middle of the room is what he's doing with this command here. So point towards eject area. Point towards eject area. And then we're going to move forward. So we're testing for collision. We're going to move in the direction that we're already moving just a little bit, 0.5. So if we were just touching the wall, basically if it detects that we touched the wall, we might be halfway in the wall or we might be at the far edge of it. So what we do is turn around to face the middle of the room. No matter which direction we're in, we're always going to face the middle of the room. And then move just half a pixel over. And then we're going to point back in the original direction. That's what that temp variable is storing, our original direction, right? So flip back to the original direction, point in direction, temp variable. So he's going to go back, he's going to turn around, move a little bit back, flip back to the original position. So now he's going to check again if he's touching a wall, because we're going to use this command over and over again. And we're going to keep moving him half a pixel at a time until he's finally free of the wall for sure. And so we do that by adding this temp collision block over and over and over again in our code. And this is the cheaty way. Let's just duplicate this, and we'll duplicate those two blocks. And we'll duplicate the last block. So you see how quickly I put 5 of them in there. So that will detect our walls very, very elegantly, so it doesn't appear that we're popping backwards. And the cool thing is here, it'll just keep running as many times as it needs to until it's no longer touching the wall, 5 times basically, which should be more than enough because we're moving at a speed of 2, right? So we couldn't be more than 2 inside the wall. So 5 will always take us outside of the wall here. Let's try that out here and see what happens. So click the green flag. I have to wait 3 seconds. If I try to move right away, that's not going to work. So let's move over to the wall here and try to bump into it. And you can see that I'm actually sliding along the wall as I try to move into it. So this worked great with dynamic walls like this. I think my collider is a little bit misplaced here because it appears that I'm going too far in one direction. I might have grabbed it and dragged it somewhere. So let me go have a look at the code here. I think we just have to move it into a proper position. So let's go over to the scaled cafeteria mask here. And we're just going to add a little bit of code to make sure it's centered properly. I think I just accidentally dragged it somewhere as I was playing around and showing you stuff. So the new location for this is going to be, it's not 0, 0, it's a little bit offset. It's 3x and -1y. And we don't actually want it to be visible here. So we're going to use that fun trick. If you want to collide with something that's invisible, you cannot hide it because you can't collide with stuff that's invisible, but you can make it almost invisible, so invisible that the human eye can't see it. And we do that by going to our looks commands here and going set ghost effect. So a ghost effect of 100 is invisible, and it turns out that a ghost effect of 99 is pretty much invisible, but you can still do collision detection on it. Okay, I think we're ready to test this out now, so let's maximize our screen and give her a try. You can see that our background has disappeared now, and you can see that we're keeping away from this wall quite nicely. This will look better when our animation comes into play in just a couple of minutes. Because playing this game, I noticed that it was quite a bit more responsive once the animations were changing. You'll see that we press against the wall and it kind of gently bounces off of it, basically. So let's finish this and get the animation going, and then it'll make a little bit more sense. So in order to, the next part of the code though is this table collision part. So it's the same idea as this. We're going to do it 5 times here, but it's going to be for each table. Let me grab one of these blocks of code here. So we've got this custom block. I showed you a little earlier what it looks like. And we've got one of these lines of code for each of our table. We're not going to collide with them multiple times here, but we're basically going to put the XY coordinates of the center of each table down here for each of these different for each of these different tables, and that's going to get that collision detection going. So I won't show you all the details of the gory details of how that math was done here, but we just know we have to enter the numbers here. So my first number is 63 and then 83. Actually, let's get all 5 of these down here. And the 5th one, okay. So 63, 83. Then the next one's minus 76, 83. And then the third one is 63, and then minus 61, and then minus 76, and then minus 61, and then 0, and then 10. There we go. So we've got all those numbers in place here, and that should get, through the magic of these custom blocks here, that should do all the work that we have to do here to have our guys be able to navigate around these round tables here. And again, I won't explain the gory details of how that math works. Okay, let's try it out again. We'll wait our 3 seconds for the game to start, and then here we go. And you can see that I can kind of get to the table. I can get to the benches, but I can't step on the table no matter what I do. I don't get caught on any of the edges here. You can see that this is a very smooth movement system that no matter what you're doing here won't slow you down. So even if you're moving diagonally or you bump into walls, you'll just keep sliding along them here, which is really, really handy. You can see it's quite difficult to do collision detection around a round object like this. So bravo to Jeffrey for coming up with some really cool code to work that out for us. Okay, next up here, we can get our animation running now. So let's go ahead and do that. We'll go to back to our main imposter block of code here. So after we've done all these collision detections, the last thing we're going to do is just change our animation state. So we need an if-else statement in here that's going to determine whether we're in a walking or an idle animation. So if I move this frame, so let's go grab an equal to sign. We're checking that variable called moved this frame. If move this frame is equal to 1, which means I did move this frame, then we'll get into a walking animation. So let's go, and this is how easy this animation system is once you get it going, right? Just have to enter the costumes in there, give them the right name, and just command them around using this block here. So I'll go walking. Got to spell it properly or it will not work properly. The frame rate is 0.03 and the loop is 1, meaning yes, it does loop. And now we'll grab a second version of this block, set animation, and this will be the else, meaning we're not moving. And in that case, we'll change the animation to standing. This is going to be the same thing we put at the beginning of the game. And then 0.07 and then 1. Now this is where the game starts to look like fun, guys. So let's have a look here at what this animation looks like. And so he's standing around his idle animation. And then as I move around, he does a little bouncy thing. This is starting to look familiar to you Among Us fans, isn't it? So it looks pretty realistic. This is quite legit, this animation system. Jeffrey grabbed all the original animations from the Among Us game, and I think he did a fantastic job of recreating that game experience for you guys. Okay, looking good. Now, there's one last command here that goes outside of that if-else statement. Later on, we're going to be using a draw command using the pen tool to draw a lasso that's going to connect you to the person who you just murdered. So you're kind of chained to him until you can drop him out the airlock. So at the end of every frame of animation, we have to erase that. Now, we don't even have the pen tool on here yet, so let's go ahead and add it. I'm going to click on Add Extension down here at the bottom of the screen. And that will get us to a menu where we can add our add-ins. Here's the pen add-in. We're going to grab the one here that says Erase All. And we're going to put it down at the bottom. That won't do anything yet, but pretty soon that is going to work for us. So we are pretty much done coding the imposter for now. Tomorrow there'll be some more, or sorry, next time there'll be some more code to tether him to the other guy, to the guy we just murdered. But everything's working quite nicely here. Our animation's going smoothly. and everything looks really good. So perfect. Okay. Now, next we'll get over to the crewmate. So as I said, in today's game, we're going to have the crewmate spawn. They're going to come in a circle around this table. And then we're going to have them moving randomly around the map. And then we'll give them, we'll be able to catch them later. So we're just going to get everyone moving, but they will be blind to each other. So the actual gameplay will come in part 2 here. Okay, let's go to the crewmates and start working on that code. So we're going to need our Chromeworks animation system as well. So before we go over there, let's go ahead and grab some of this code and drag it over. So here's my my 2 blocks of the Chromeworks animation system here. So this one here that says define set animation name, I'm going to drag that over to my crewmates and let go. And I'm going to grab that second block here, which also controls, which is the other necessary part of this animation system. We'll pop that in there. Okay, we are inside the crewmate sprite now, and we're ready to start coding it. So Jeffrey used global variables when he made the imposter, and he said that was a mistake, but he didn't want to go back and change it. So the result of that is that he has to he had to make a new variable with a different name for this. So normally when you're using this animation system, you shouldn't have to change anything inside it, but because we're using different variables for the 2 different versions of it, we're going to have to go back and change these variable names. So this we're inside the define set animation. We're just going to set this to crewmate animation wait time. We're going to set this one to crewmate animation ended. It's just the exact, animation ended. It's the exact same names of variables, just with the word crewmate added. So this becomes crewmate animation name, and this becomes crewmate animation looping. Good. And this last variable here, we're actually going to pull this out, and we're going to put in this red bubble here that says name here, and that's just going to fill it in with the name that you typed into the original code block there. Okay, down here we have to do the same thing. So I'm going to right click on this variable, change it to crewmate animation name, or animation wait time, sorry. And this becomes crewmate animation name. And this becomes crewmate animation looping. Jeffrey did this to save time, but he actually ended up wasting a lot of our time. Please feel free to send him hate mail. Okay, crewmate animation name right here. Crewmate animation if crewmate animation looping equals 1 crewmate animation name, switch costume to 2 crewmate animation name, else switch costume to crewmate animation name here again. Oh no, it's number -1. Let's make sure that's in that rubber bubble properly. And then we set crewmate animation ended here. All right, and I'm pretty sure there's one other one here, crewmate animation ended. All right, so I know this is a little confusing here. I'm just going to show it to you. If you're watching this on video later, as I'm sure you are, you just pause the video and just check all these variables to make sure they're good. And we won't really know whether I made a mistake here until these crewmates start running around and animating themselves. Okay, let's carry on with the coding here, though. We're just going to pretend that didn't happen. And let's start with the green flag here. So let's create some space over on the side here. I'm going to add a green flag block. Move it a little further over to the left. Blow it up a bit. Okay, so let's start by initializing some variables. We'll go set variable. Let's go to my variables here. Set crewmates alive to 0. That variable is going to control whether anyone is left alive. Basically, we're going to make that number go up. So that's just a count of the number of crewmates who are in the game. We start at 0, and then every time we clone a new one, we change that by 1. And we're going to have another variable called set crewmate suspicious. So what's going to happen in this game is your guys are going to be wandering around oblivious to you unless they watch you murdering somebody. Now they're going to try and run to an alarm and turn you in when that happens. But if you get rid of the body before that, they are going to be afraid of you, but they're not going to be able to actually do anything about it. They won't be able to push the alarm button. And so they're going to just basically stay away from you. They can't talk to the other characters, so they're just going to hide from you and make sure that they are not the ones who are getting murdered. But the jig is up, and for the rest of the game, these guys will know that you are the imposter. Okay, so that's good. We're going to go set rotation style to left, right here. We turn that off at some point so that we can have the guy spin around when he's being ejected from the ship. So right now, though, we want to lock it, or actually when he's caught as well, we want him to go. So right now, we're going to make it sure he's upright when he's moving around, but then when we snare him, he's going to be spinning around, so we're going to change this in a little bit. Okay, we're going to use some drawing effects now. Let's go erase all here again. We're going to set our pen color to black, and we're going to set the pen size to 2. Set pen size. Oh, that's not the right one. Oh, there is an actual pen size one here. Sorry, set pen size to 2. Okay, the 4th block I tried. Finally, it's the right one. Set pen size to 2. So that's preparing stuff for when this guy does get killed. He's going to be chained to you using this pen tool. We're going to draw a line between you and him, and it's going to kind of look like they're connected to each other. Okay, our new guy is going to hide. This guy's a master, and we're going to use him to make clones of himself. Let's tell him to point straight up, so point in direction 0. And now we're going to start making new ones. So we have this variable called crewmate index, and it's a local variable. So let's go set variable crewmate index. Crewmate index, there it is. So this variable is going to keep track of the ID number of everyone. Scratch doesn't know, out of the box, Scratch doesn't know the difference between one clone and another. So you have to kind of stamp them with an ID number when you make them. And that way you'll be able to say, clone 1, you do this, and clone 2, you do that. Otherwise, if you give a command that goes, when I start as a clone, all the clones are going to do the same thing. So this is why we're setting this crewmate index. We make it a local variable, and then as we're creating them, we stamp them with this number across their foreheads, basically, that lets them know, oh, I'm number 1. Okay, we're going to use some color effects to change their color. So let's just reset our color effects here. We'll go to our looks commands here. We'll go set color effect to 0. That'll reset all our colors, and then we're going to color each of our new guys a different color. Okay, then set color effect to 0. Oh, the crewmate index was supposed to be set to 1, actually, because we're working on our first crewmate. Forgot about that. Okay, now we're going to store the current position where our crewmates are walking in a list. We have a list variable here already made that's called crewmate X position and crewmate Y positions. We're going to store all of that so that we always know where everyone is, and that's going to be important later on in our game. But right now, because we're restarting the game, we're just going to delete all of their positions, delete all of the X positions, and delete all of the Y positions as well. All right, we're good to go here. Now we're going to start creating these. There's actually going to be 10 characters in this game, you and 9 crewmates. So let's get a little loop around here. We'll create 9 friends for us to murder. Okay, repeat 9, and then we're going to go change colors. Looks, change color effect. Change color effect by 20. And now we're gonna send the clone to the middle of the screen and then rotate him around. We want them all circled around this table, and you can't use math to have them go around the edge of the circle. It's super complicated. So the easier way to do it is bring him to the middle of the circle, point him in a direction, then tell him to move, and then point the new guy in another direction, and then tell him to move, and everyone ends up going off in a different direction. If they all move the same distance, they'll be in a perfect circle. So we're just using some simple math to get these guys arranged around in the circle. So change color effect by 20 is basically going to make each one of them a slightly different color, so they all look different from each other. Okay, so let's send them to the middle of the map. This is our master guy who's going to be making clones of himself. We'll tell him to turn 36 degrees. So every time he comes around this loop, he's going to go 1/6 of a full, or sorry, 1/10 of a full circle around, so that they'll all be perfectly evenly arranged around the circle. Now we're going to move them from the middle to the edge of the circle. So move 70 steps. That'll pop them into the right location. Then we need to change their Y, or set their Y coordinates. So after they get moved a certain distance away, we're going to tuck them back in and bring them a little bit closer to the table again. And I'm not quite sure why this works the way it is. We're going to be using this math a couple of times though. So this has to do with keeping them smoothly connected to the table. So let's go set Y to Y position times 0.7. So let's go grab some multiplication, and we'll go times 0.7. And then we're going to go set Y position. There we go, set Y. So we're basically just going to, we're going to move them out 70 steps and then bring them back in again. And I'm kind of curious about what that block does, because I don't quite understand it myself. So we're going to run a little experiment here in a second and see what it looks like if we don't do that, if we don't set this Y, because I'm kind of curious about that. But let's finish our code first. Now we're going to add all our current positions to that list here. So let's go to our list commands here again. We're just going to start storing all of their current X and Y positions. We're going to put them onto a big list. And this list is how we're going to figure out who is closest to us, because we have to look at the positions of each guy and pick who is the close one to us, so that we can figure out whether he can detect us. If the closest guy can't detect us, then all the other guys can safely ignore us as well, of course, right? So let's go add thing to something. So this is still inside this loop here. We're going to go add X position. So add what our X position, what the current X position of the clone is to crewmate X positions. Then we're going to go add our Y position. Oh, we can't change that from here. So we'll add our Y position to crewmate Y position. So we've got two different lists here, and they're always going to keep track of what the X position. One list is going to keep track of everyone's X positions. The second one's going to keep track of the second X position. So our index 1 is going to have the first X position and the first Y position on the list here. Okay, now we're going to go ahead and create our clone. Create a clone of myself here. And because we're creating new guys, we have to change those index numbers and the number of people alive. So let's change some variables here. Change crewmates alive. So many variables in this game, by 1. And we're also going to change our crewmate index by 1. So we're going to give our new guy a new stamp on his forehead, as I said, and we're going to change the total number of crewmates alive by that number as well. And that'll just keep count for us here. We just got a little bit more to go here. I might as well just finish off this block of code here. So we're going to go wait until, this is just the game ending portion here, but so we've only got a couple of blocks left, so let's just power through this. So let's go to our control blocks. We'll grab a wait until, and we're waiting for crewmates alive to equal 0, meaning our last guy has gotten killed. So let's grab a little bubble that says crewmates alive, and we'll put that variable into it. So it's just going to keep hanging around here in this loop until crewmates alive is equal to 0. Crewmates alive. So many variables. Okay. So we're going around 9 times here, and then we're going to exit the loop and then sit here and wait for our crewmates to be dead. And when all our friends are dead, we're horrible, horrible people. We'll go to our events and we'll broadcast a game over event. Game 1. New message. game 1, and then later on that'll show up the proper screen and everything will look great. Okay, we're ready to test this out here, so let's have a looky here. As soon as I click the green flag, you'll see it waits 3 seconds, and then it should spawn all our guys, but all our guys are invisible. Ugh. Okay, again, I went a little too fast here, eh? So we've got a when I started the clone block here somewhere. Let me find it. Here it is, when I started the clone, and that's going to make these guys visible. So let's go underneath here and add a when I started the clone. Set a variable. Let's go set a variable called can play alert sound. And so this determines whether he's in a position where he's close enough to you to detect you. And so 30 pixels is the distance he's going to have to be away around you to see you. Otherwise, you're going to be invisible to him, basically. So we're going to set that distance to 30. Okay, so we want all our guys facing the table at the beginning of this game here. So we're going to flip them around, basically have them facing the table for 3 seconds while everyone's being spawned. And then they're going to flip back in the other direction as well. So let's go ahead. We'll go to our motion blocks here. We'll tell them to turn to the left 180 degrees. It could be turned to the right as well, though, of course, because it doesn't matter. Both of them are the opposite direction. So turn around. Okay, let's add a show block now to make our clones visible. And now we're actually at a point where we can test that. I was just talking to Jeffrey about this mystery block that I was asking about before that I wasn't quite clear on. So why do we change our Y position? We're making them go an equal distance away from the circle, but you'll notice that our table isn't actually a circle. It's an oval because of the 3D perspective. So we want it to go over an equal distance to the left and to the right, but when we're moving up, when we change our Y coordinate, we want it to be only 70% of the distance. There's that Pythagoras coming back into it again. They've taken a shortcut and they're farther away from the table than we want them to be, so we bring them closer again. And that will keep them into a nice looking little circle as we tighten that up again. So let's maximize our game and give it a look here. And they're beautiful. We can see our characters in a nice little oval around our other oval here. And every one of them is a different color of the rainbow, which is pretty awesome, I think. So it's a really nice little setup here. And it looks like they're all ready for action. So now we can get them doing something interesting. Let's get them animating. And so we're going to do that next. So we're going to use our animation system again here. We've already customized it a little bit. So let's go set animation to standing. The delay is going to be 0.03 again. Whoa, one too many zeros there. And the looping is going to be 1. And then we're going to wait 3 seconds. So they're going to be standing there for 3 seconds. So let's go control. And our character is going to be standing there for 3 seconds as well. And then game on. And look out, crewmates, because the imposter is coming for you. Okay, let's set their animation to walking. We'll go to set animation, walking. And the delay there is 0.03 again, and the looping is 1. Okay, and now here's where things get a little bit complicated again. Actually, let's just go watch their little walking animations first before we get into that. So they wait 3 seconds and then they start running. There we go. And because they're not actually moving, they're not switching from one animation to the next. Our guy is, though. But you can see they got themselves into the running animation, and there's going to be a little bit more to make them switch frames here when they start moving. But we're not quite there yet. Okay, so we've got this variable here that we're going to set. Let's go set our variables. And it's called turn coefficient. Now that's a lot of complicated math talk, but we're basically going to pick a random number from 0 to 360 for our guys to turn in. This is a fairly complex bit of math, and Jeffrey says it's the most complex math that we're going to be coding in this whole thing. So again, this is something that you don't completely have to understand, but the basic idea is, as I understand it, we're we're getting these guys to move around in a way that looks natural. So every time they start moving in a direction, they're kind of going to keep moving in that direction. We can't have them randomly picking a direction each time, or they're going to just be crazy all over the place. We want them to keep moving so that when they start moving in a curve, they kind of keep moving in a curve. And when they start moving straight, they keep moving straight for a while. So we're making them want to keep their motion really smooth, but we're doing that with a little bit of math. So I don't think I'm going to be able to explain this to you in a way that makes sense. So you're going to have to trust me on this, guys. It's just a little bit more complicated than I really want to teach you right now. But some of this stuff, this is why I want you guys all taking math when you're in high school, right? So that you'll be understanding this stuff. So turn coefficient, pick a number from 1 to 360. So that's going to pick basically a starting angle. And so we're picking a random number here. Then, okay, we're going to start moving. So we're flipping in the opposite direction first. Let's tell them to turn left 180 degrees. They don't need to face the table anymore because they're running around now. And let's get the forever loop that gets them moving here. So let's go control forever. And now here's where we're going to do some crazy turning math here. So let's go to our motion commands. We'll tell them to turn right. Okay, so we need a multiplication sign in here. Let's go ahead and grab our multiplication sign. So we're going to turn multiplied by a random number. So that random number is going to be between 2 and 10. So the minimum they can turn is 2 degrees, and the maximum they can turn is 10 degrees, basically. So they don't turn too quickly. So let's pick a random number from 2 to 10. And we're going to make that number smaller by using a sine function. Now, we used a sine function a couple of weeks ago. You know that it moves smoothly back and forth between 0 and -1 in kind of a beautiful sweeping curve. And this is how we make things look nice and natural. So we're going to grab the sine is here under this block here that says absolute or absolute value. So we're going to go sine of turn coefficient. So we're going to take that number of the direction that we're facing in, and we're basically going to convert it into a number between -1 and 1, and that number is going to affect what direction we're moving in based on these angles. So it's going to pick to turn left or pick to turn right based on that angle. So let's put that turn coefficient into there. Now, as I said, don't get put off by this math here, right? There's a lot of fun coding to be learned here, and just because there's something a little bit complicated that you are going to have a hard time wrapping your heads around doesn't mean that you can't get a lot out of doing the rest of this project. So stick with us here, and the rest of it will make a lot more sense. That was the hardest bit, okay? All right, now we've got that basic direction. We're only allowed to change it a little bit at a time. So we're going to change that turn coefficient now. Change turn coefficient. And so this is how we're going to make sure we're not moving too fast. We're just going to change that number a little bit at a time. We're going to change that by a random number from 5 to 10. Pick random 5 to 10. Now you'll be able to see when these guys move around that it looks quite smooth and quite nice, and they don't do anything radical. I've tried experimenting with this stuff before, and I've had very poor results when I've tried to make AIs move around the screen. So I'm actually really impressed with this system in here. Okay, so we've got to get those same table collision blocks in here. We're checking to see if they're smashing into a table here. I don't want to reinvent the wheel, so I'm going to go back to my Imposter and grab those 5 blocks of code with the numbers in them. Let's see if I can find them quickly. They're down here. So I'm just going to grab these blocks of code and duplicate them. And I'll try and put everything back into its proper place again. So this is all inside the one loop. Okay, drag that over to our crewmates here. I can trash these back to the crewmates, and that should have popped up. There it is. So we're going to, inside this loop here, we're going to test for collision 5 more times. And this is where the wall collision happens. So we're going to go put an if statement inside here. If I'm touching the wall collider, and that again is called, we'll go to our sensing blocks, touching scaled cafeteria, what's it called again? scaled cafeteria collider. And so if they're touching, we're going to have them spin around. We'll turn around a little bit, not flip around, but we're going to go turn, turn right. I don't think this matters either way. Turn. And then we're going to have them pick a random number. So this is them kind of bouncing off the walls. It's not going to be directly backwards. It kind of bounce off in a direction. So we're going to pick a number from -100 to 100, and then they're going to keep moving. And then after that, we're going to test for collision with the walls a couple of times. So let's go test collision. Actually, yeah, so let's go test collision. We don't have the test collision block here, so we're going to have to grab that from the Imposter as well. We're using the same code over again. So we'll drag that over to our crewmate. And so now we've got the test collision block in here. And we're going to test collision 4 times, basically. So let's go ahead and do that. Duplicate. I'm not sure why it's 4 for this guy and 5 for our character. Maybe these guys move a little slower. Yeah, okay. And I think we're actually in a position where we're ready to test this. Let me check my documentation one more time here and make sure that we're in the right place. Yeah, actually, this is all the coding I want to do. Everything else below here in the code is collision detection and has to do with not touching walls or whatever, but touching your guy or getting caught by your guy. So we're going to do all of that next week. Let's give this one last look here and make sure everything's looking good. And so our guy should be kind of running around like crazy a little bit. Here we go, 5 seconds, and then go. Yeah, they're all bouncing around the screen. Their animations aren't flipping the way we expected them to, though. And they're not bouncing off the walls properly. Let's go have a look and see what I forgot. There's something messed up here, though. Okay, some really obvious stuff that I forgot when I was coding, so let's just go back and fix that. Number 1, this define test table collision, we didn't actually drag that over, so this block, we just had to drag it over from the Imposter. So we're testing for a collision with the tables, but we don't actually have the code here that will do anything about it. So we just need to borrow that code from our Imposter. And the other thing we had to do was this animation code here. It doesn't start with a green flag, of course, because we're animating clones. So we have to. So I just pulled the green flag off of here and put a when I started the clone. So those are the only 2 bugs in my code here, and now everything should be working smoothly. Let's give it another test. And 3, 2, 1, and they're scurrying around like crazy and doing really great. So this looks a lot like Among Us. Hats off to Jeffrey for doing a fantastic job coding this. Do you see the smoothness of their motion? They really look like little intelligent guys who are running around the screen. They don't have that weird clunky look that AI characters have sometimes. Now the math is a little bit complex, as I said. We're using some trigonometry functions here. And I don't expect you guys to understand it, but I do expect you guys to appreciate it, because this is just a fantastic bit of coding. So there we go with part 1. I think this is just going to be a great project. It's really fun and fun to play, actually, too. I spent quite a bit of time today just fooling around with it, trying to finish it. So the good, challenging game. It's actually harder than it looks to get these guys separated from each other enough that you can actually toss one of them out the airlock. So fun little single player game, and I'm really excited to teach you guys the rest of it. So next week we're going to do the rest of the play mechanics where we can actually attack these guys and toss them out the airlock, and we'll have the game more or less ready to go, the basic play mechanic ready to go next week in part 2. And then part 3 we'll do all the animations and stuff and the cool music and the stuff that makes it really feel like an Among Us game, and you saw some of that in the demo at the beginning of this. So until then, thanks a lot for watching, guys, and I will see you again next week.